last semester with using 2D CAD to draw plans, ground plans, elevations, sections, 2D things. What we're going to be looking at this semester is using the program and its more powerful features to draw 3D things, such as here is a Vectorworks rendering that's a 3D model of production of Les Mis in the round that I did in Boston a couple years ago. So this is all in Vectorworks except for the guy. Was put in Photoshop, but the rest of this is all three-dimensionally modeled. So you can see that you can model scenery, props, lighting, gobo effects. All those sorts of things are available to you to do in Vectorworks. Here's another example. This is a joint UCF Orlando Shakes production of Nicholas Nickleby that we did a couple years ago. Once again, all done in Vectorworks with the exception of the people that are actually borrowed from the costume designer and put in Photoshop, but all the rest of it is Vectorworks. Sort of another example here is a show I did in Fort Myers last year. This is a more traditional set. This is a box set. It's an Agatha Christie play called The Unexpected Guest. And the reason I brought this third one up here is because I want to talk about one of the things that 3D CAD allows you to do is to create 3D models, but also generate 2D plans. So you'll notice that this is a 13-page PDF file. So the first page is a rendering of what the set's going to look like, but the rest of the document is the plans that we would be used to from last semester. So here's a ground plan and a technical plan and a section and a bunch of elevations that are more similar to what we did last semester. The thing that's I want you to know about this is none of this was drawn, with the exception of this drawing right here, none of this was drawn in 2D. All of this is it was drawn in 3D, so it's all of the elevations are taken from the 3D model of the set. So if I open up the Vectorworks file, there we go. Okay, so here's the 3D file of that set, and this is all of the drawing. You'll notice there's no other 2D drawing here anywhere. All of the other sheets, for instance, the ground plan was, and it's going to take just a minute because this is a big file, but all of this is generated from that 3D file. So the ground plan is a top view, a looking down view at the set that has some graphic attributes that have been applied to it, so it doesn't literally look like the top of the set. Because if we go back to the 3D view and just look at it from the top, you'll see that that looks similar to what the ground plan looks like, but there's all sorts of, it's not a very attractive looking plan. That's the actual top view of the set, and then this is what the ground plan itself looks like. So they're based on the same file, but there's some graphic stuff that's been done. But I didn't have to redraw this. Once I drew the 3D version, I was able to just use that to generate the 2D version. So for the ground plan, the technical plan, the section, for any of you who struggled with sections last year, the sections automatically can generate, so you can just cut the 3D set in half, and what's happening here is it's rendering. It takes it a minute to it's thinking to do all the work here. That's what the little beach ball is, and eventually it will hopefully fill in the section, and there we go. Alright, so instead of me having to draw all of that again, this is basically just a side view of the 3D model with part of it cut away and removed. So all of the rest of the plans, and I'm going to go back to the PDF here because it's faster to look at, all of the rest of these plans were generated from that 3D model. So that's one of the, to me at least, exciting things about the 3D is you don't have to keep drawing the same door. Once you've modeled it, you can use it as part of the rendering, you can use it as part of the section, you can use it as part of the elevation. Another thing that's useful is if we look at lighting. So I'm going to look at the West Side Story light plot. So this is the light plot that any of you are lighting designers. This looks like a normal light plot. view, but this plot is actually all drawn in 3D. So if I look at a 3D view of it, and it's going to take just a second. So now I have not just the top, the flat plan, but I can look at this in 3 dimensions, and this is really helpful for being able to determine if lighting particular instruments will make their shot if I'm trying to shoot through a wall or something. So there's a lot of functionality built in here that you can get from the 3D model that you can't necessarily get from just the 2D model. You also can do things like, I'm going to go to a 3D perspective here, and it's going to take just a minute for it to so if I render this, and we'll talk about exactly what that means later, but I can actually even look and see, okay, what are these lights gonna look like when they're turned on. So what I have it here doing is there's some purple side light that's coming from both sides of the theater, coming from over here and also coming from over here. So I have just those purple side lights turned on right now, and I can get sort of an idea before I walk into the theater, given the 3D modeling of what the lighting is going to look like. So as I'm creating the design, I can use the 3D model to help me visualize it. So those are some of the things that you can do with 3D modeling. So throughout the semester, we will be doing some of the things that I just showed you. You'll, by the end of the semester, should be able to create your own 3D models and renderings of theatrical spaces, of light plots, and also of individual 3D objects such as props. In order to do that, we're going to start at the very beginning, and we're going to talk about some 3D CAD basic concepts in the video today. So what we're going to be looking at for the next few minutes is some of the tools that we'll be using. Many of them are the same old tools we were using last semester, plus some new ones. We're going to be talking about 3D views, planes, rendering mode, hybrid objects and symbols, extrusion, and sweeping. And I will say in advance that like many things in life, and particularly many things in theater, it's difficult to talk about some of these things without talking about others, because they're all sort of wrapped up together. But I will try to separate them the best I can, and we'll see what happens. And then once this video is over, there will be a tutorial for the very first project for this week, which is due next week, and that project is intended to sort of introduce you to these basic concepts. First thing I want to talk about is some tools. So if we open up Vectorworks and look at it, we'll see that it looks exactly the same, because Vectorworks has always been in 3D. We've only just been using the 2D tools in it. But so all of the basic tools that we were using last semester, we'll still be using this semester. The lines and the squares, those sorts of things. The 2D polygon tool will use, and then we'll turn that into 3D polygons. There also are there is a 3D polygon tool, but so those tools are going to be the same. Just as a refresher, just to make sure that we're all on the same page here, I'm working in the Spotlight workspace. So tools, workspaces, Spotlight. So just wanted to let you know that. So in addition to the basic tools we've been using, we're also going to be starting using more of the tools that are down here in the tool sets. So the first tool set that we used a little bit last semester, but we're going to be using more this semester, is the lighting tool sets. And lighting in Vectorworks is also always inherently 3D. Sometimes you only see the 2D version of it, but it's built to be always inherently 3D. So we'll be using some of those tools. The actual 3D tools are the third one over here, 3D modeling. This is the tool set that looks like a red sphere and a green cone and a blue cube. So all of these are all 3D tools that we'll be using throughout the semester. And also here in the building shell, these are also 3D tools. These are sort of architecture specific. They're walls and doors and windows, but they're also often used for scenic design. And then the visualization tools are the tools that you use to look at the 3D models and things after you've drawn them. So we'll be working with all of those too. So we'll be adding more tools here to our repertoire of tools that we started with last semester. And we'll be talking about many of these individually as we work on projects. So the next thing I want to talk about are 3D views. So if when we were last semester we were just looking at everything in top plan, I don't believe we ever looked at anything in another one of the views over here. So now you'll see that there are lots of different views to choose from. And let me open up another file. So here's our six-sided box. So we talked about this before, that when we were drawing ground plans we were looking at things from the top, and when we were drawing elevations we were looking at things from the front, and when we were drawing sections we were essentially looking at things from the side. But in reality we were really just drawing everything in top view, and we may be drawing something from the front, but we weren't actually looking at it from the front because it was really in 2D. But now that we're going to be moving into 3D, we actually will have the ability to look at things from different views. And so we want to look at some of those different views. There are two different types of orthogonal views. There are the standard views and the isometric views. And right here in this drop-down menu, you have all views. Top plan is a specific view that we're going to talk about later, so ignore that for right now. But other than top plan, we have 6 of the standard views. They're what you would expect: top, front, right, bottom, back, left. They're in a strange order to me. It seems like top, bottom, front, back, left, right would make more sense, but this is the way they are. So if we switch to top view, you'll see what happens. We actually rotate our view and are now looking at the top of our cube. So if we switch to front view, it's going to rotate the view and we're actually looking at the front. So you would imagine right is there, bottom, rotating and looking at the bottom, back there, and left. You also can use this tool, what's called the flyover tool. Did you know you can invoke that? I did. To rotate around an object freeform. So if you just want to, or trying to get a good look at something, you can use the flyover tool to just rotate around it. But if you want to make sure that I'm going to rotate it so that I'm in top view, and it looks like I'm in top view, but if I want to make sure I actually am sort of mathematically in top view, because you'll notice here it says custom view, I have to actually switch to top, and it will look directly at the top. So those are the 6 standard views, and then there are 8 isometric views. So the standard views assume that you're looking straight at the object, whether straight at the top, straight at the front, straight at the side. Isometric views assume that you're looking at the object from an angle. It's a 45-degree angle in plan view, and also 45 degrees up and down. So if we look at the right isometric, we're looking at this at an angle, so we're looking straight at the corner from above. So we can see 3 sides in an isometric view. So the reason that there are 8 isometric views is because there's the right front, the left front, the right back, the left back. So here's the left, and then here's the right rear. They call it rear, not back. And then here's the left. But we also can look at it from the bottom. So if we looked at the lower right, so now we're still looking at the right corner, but now instead of seeing the top, we're seeing the bottom. So that's what the different isometric views look like. And I'm going to go back to top now. So something that you should be aware of as we're working with 3D, we're going to be using lots more commands, I think, probably, and you're going to probably want to get more familiar with the keyboard shortcuts. For viewing, if you are working in the lab or you're working at home and you have an extended keyboard, so this is the extended keyboard, this is what I'm talking about. The numeric keypad here contains the shortcuts to the different 3D views. So 0 is top plan, 2 is front, 5 is top. So 0 is top plan, 5 is top. Once again, we don't know what top plan is, but 4 is left, 6 is right, 8 is back. Or to switch views, I'm doing this with my fingers now. It's much faster to switch views like that than it is to pull down this menu. So you might just want to know that. Alright, something that goes a little bit hand in hand with views are planes, which is a bit of a new concept for us. 3D views are a new concept too, but I think they're just a variation of what we were doing in 2D. Planes are something a little bit entirely new. So this screen plane object is actually drawn in screen plane, and these layer plane objects are actually drawn in layer plane. So if I go into 3D mode, so here's what's happening. You notice the screen plane does not move. It's as if it is actually drawn on the screen. I can zoom in and zoom out and it will get bigger or smaller, but other than that, no matter what view I go into, whether it's through rotating or through using one of the custom views. So you'll see now that the objects that were drawn in layer plane, since they're just squares from the side, they just look like lines. If I go into really any of those views, since those are not really 3D objects, if I go into isometric, you'll see them. But so this is an important concept to remember, that things that are drawn in screen plane are inherently sort of 2D objects, and things that are drawn in layer plane are inherently 3D objects, even though in this case they don't really have a third dimension. They're flat. They're basically just like a piece of paper. That's, if you think about that, it's not really, you know, a box is 3D and a piece of paper is really sort of 2D if you think about it that way. So that's the difference between layer plane and screen plane, is that things that are drawn in layer plane are true 3D objects. Things that are drawn in screen plane are just 2D objects. This will become important later. So the next topic I want to look at is rendering modes. Rendering is a type of artistic output basically from a model. So modeling is the creating of the shapes, and rendering is basically how those shapes are displayed. So if we go back to our six-sided cube here, so we're in a rendering mode called OpenGL. So over here there's a little menu with a teapot on it. No one's ever really been able to explain exactly why the symbol here is a teapot. My theory has always been because in the old days it used to take so long to render things. Like for instance, when I was in college, in order to draw this green rectangle in 3D on a computer, it would have taken hours. I could have gone to the dining hall and had a cup of tea and probably dinner and come back, and it would have still been rendering. So it takes a while for the renderings to happen. So that's my theory as to why they use a teapot as if you guys want to think about it this semester and figure out your own theory, I don't know. But at any rate, so this is the menu for rendering modes, and the most basic rendering mode is wireframe. So wireframe is kind of what you all sort of expect, I would imagine, when we talk about 3D modeling in the computer. It's sort of this bare bones where everything is transparent, and it looks like it's made up out of wireframes, hence the name wireframe. It can be a little bit confusing, but it is the fastest mode. So if you're doing something that's a really complicated model and you're doing it, spending a lot of time sort of rotating around it or looking at it, and it's taking a long time for it to redraw, this is the fastest mode. Wireframe is the fastest mode. The sort of next fastest mode is OpenGL. This is a rendering mode where everything is filled in, but it's not really photorealistic. This is not the mode that any of the renderings that I showed you at the beginning of this video were done in, but this is the mode that you're probably going to want to spend most of your time working in. So OpenGL is kind of a nice compromise between the really fast wireframe mode that's very fast but a little bit difficult to interpret sometimes, and some of the slower, more photorealistic modes that take a long time to render. OpenGL is pretty simultaneous or responsive, immediately responsive, unless it's a really complicated model when it might take a little bit of time. The RenderWorks modes are the most accurate photorealistic modes. They're the high level rendering. They're the ones that take the longest. Now in this particular model, it's a cube and there's no lighting involved, so you're not going to see a whole lot of difference. I'm going to go ahead and do a final quality renderworks. You're not going to see a whole lot of difference. You'll see it looks a little bit better than OpenGL, but did you notice how long it took? You can actually watch it render, so it takes much longer. So typically what I do is work in OpenGL and occasionally in wireframe and save these for the very end. Once I know everything is correct, then I'll do a final renderworks. It sometimes can take, even now, like those renderings that I showed you at the beginning of the video probably took, some of them, 20 to 30 minutes to output in the high quality mode. So just be aware of that. Some of the other rendering modes that are available are hidden line, which gives you it's basically like a wireframe with all of the lines that you actually couldn't see are hidden, hence the name hidden line. So here's the wireframe, and we know that in reality we can't see this line because it's behind, it's on the back of the cube. We can't see this line and we can't see this line. So if I go into hidden line, it just is still just a line drawing, but it hides the lines that you can't see. So that's hidden line. Dashed hidden line will do exactly what you would imagine. It will dash the hidden lines that are behind. I never use polygon. Polygon is, let's see what happens here. Yeah, it's a kind of an odd rendering style that I honestly never use. So I would advise that you don't use it either. I don't know anyone who uses it. I'm sure there must be a reason to use it since it's here, but I don't think you'll find it being used very often. Sketch is a way of adding a little bit of hand-drawn flair, if you will, to a wireframe rendering or to a hidden line rendering. You can set the hidden line renderings, and we'll talk about this towards the end of the semester when we're talking about final output. You can set the hidden line renderings to Sketch. But mostly we're going to be working, and then there's some other artistic things, and there's some options. We'll talk about all this later, but what I want you to know now is that mostly you'll be working in OpenGL. If you find that you're wondering why your object isn't the way you expected, for instance, if you thought you drew a green cube but all you're getting is this, and you wonder why is my cube not green, that's because you need to be in one of the rendering modes that is not wireframe. So that is rendering modes. Okay, next we're going to talk about hybrid objects and symbols, and this is where our top plan view comes in. One of the reasons that Vectorworks was adopted quite early by the entertainment industry, and particularly by the lighting industry, is because it was one of the first programs to present this idea of hybrid objects, which essentially means that an object can be have both 2D information and 3D information contained in the same object. Let me show you what I mean by that. Here is a lighting symbol. I'm in top plan view here, and here's the same symbol that I've taken apart so I can show you how it works. So this is an actual lighting symbol. This is a source 4 degree, and this is that same 4 degree. You'll notice it doesn't. If I click on this, it's a light over here. If I click on this, it's just a group. But in order to show you what's going on, so if I'm in what top plan view is it's a special view. It's a 2D. If there is 2D information contained in your 3D file, it only shows up in top plan view. So if I go to top view, I actually see what this light looks like from the top. So I'm gonna switch to side here. So these lights are both pointed sort of down at a 45 degree angle. So I'm going to switch back to top plan. And I'm going to switch back to top. So this is what this light looks like. I don't. If you think about the West Side Story light plot, in the 3D world, I actually want the light to be pointed in the right place so that I can tell what's going on. But in the plot, I don't. I want it to be a symbol. I want it to look like a symbol I would recognize. I don't want it to look like it's tilted. So this is where hybrid symbols come in, is that you can have a symbol is basically a group that contains both 2D information and 3D information. And if I look at the fake symbol here, for when you can see what I mean, that this is a representation of what's going on here. There's a 3D light and there's a 2D light during the light that are attached to each other. And so when I'm in when I'm in top plan view, which is here, it shows and this is the real symbol, it shows the 2D version, but when I'm in any of the other views, it only shows the 3D version. So let me go back to isometric there. So that's what a hybrid symbol is. You can make your own hybrid symbols. The ground plan that I showed you for at the beginning of the video for the unexpected guest set that was made from the 3D model, that was I created that as a hybrid symbol, so that in top plan it shows things cleaned up and different than it does if you're just looking at the top. So if we look at the actual light here, this light, I'm going to go to top view. So this light is focused at this focus point. If I move the focus point, you'll notice the light actually follows it around, so that it can. But when I go back to top plan view, the symbol stays the same. So because the convention in light plots is normally the lights are all drawn pointing one of four directions, either forwards or backwards or left or right. You don't normally draw them at an angle. We sometimes do in the black box, because when we get into lighting we'll talk about that, but generally when you look at a standard light plot, you'll see that all the lights are pointing one of the standard directions, even though in reality the lights may actually be pointed, I lost my focus point, where it is, the lights may be pointed somewhere off of one of the standard directions. But hybrid symbols are really a nice feature in Vectorworks that allow you to have a cleaned up top plan version of something and also have a 3D version of it attached. So that's what hybrid symbols are. We'll be delving into those a little bit later in the semester. So the last two topics I want to talk about today are extrusion and sweeping. Extrusion and sweeping are the two major methods of creating 3D 3D objects. Many 3D objects can be boiled down to various extrusions and various swept objects that are added together or subtracted, in Vectorworks, I will say, and in CAD type modeling programs. There are other 3D modeling programs that use a sort of a different approach, and that is more the metaphor is more like actual modeling, where you sort of start with digital clay and sort of pull at it. And so if you're trying to make organic things, so the folks who are modeling the 3D characters for movies and things are doing a different type thing, but in sort of architectural based modeling, extrusion and sweeping are the two big ways of getting things done. So extrusion is basically taking a 2D object and pulling or pushing it into a 3D shape. And the way I like to think about this is, if any of you have ever played with Play-Doh, they have I'm sure they still make them, I'm not that old, these Play-Doh play sets where you can put the Play-Doh in and push it out through a star-shaped opening, and you end up with a tube that's shaped like a star, right? So that's extrusion. As a matter of fact, I happen to have a video of Play-Doh right here. Okay, So the basic idea with extrusion is that we're taking a 2D shape and pulling it into a 3D shape. So I have a 2D star here and a 2D half of a baseball bat. So I'm going to select the star, and there are two ways of extruding. There's a sort of an interactive extrusion that's called push-pull. So I've selected my star, and I'm going to use my push-pull tool. I'm going to mouse over. When it turns red, I'm going to click, and then I'm just going to pull. And look, it's turned into a 3D shape. I'm going to go to OpenGL so you can see. Or I could also, so I pulled it, I could also push it. So I go down. So hence push-pull. So that's what extrusion is. It's taking a 2D shape and pulling it or pushing it into a 3D object. There's also a command under model extrude, and I can give it an actual height if I want to. It's 2 inches. I have no idea how big this star actually is, but okay, so there we go. So it's doing exactly the same thing, only I can be a little more precise with the model extrude command as opposed to the push-pull command, where I don't really have any. Oops, why is that not? Okay, there we go. I could tab and type in a distance here if I wanted. But so that is extrusion. As you can see how you can make lots and lots of 3D shapes by taking 2D shapes and pulling or pushing them into a 3D shape. However, there are some things, like for instance a baseball bat, that it would be really difficult to pull or push this shape into. And if I pull this up, I can do that, but it sort of looks like a really cheesy version of a baseball bat. It's not round, it's square because I've pulled it up. What I really need to do is I need a way to make a round object rather than a sort of squared off object. So that's why we have the idea of sweeping. So what sweeping does is let you take an object and rotate it or sweep it around itself. I like to think of this like these things. I guess you guys are still familiar with these. I don't know, this has been around for a long time, but this is a tissue paper ball. They make all sorts of different shapes of these. They come flat, they fold it up, and you take them and unfold them, wrap them around, and take the flat shape and it turns it into a spherical shape. If that makes sense. That's basically what the idea of sweeping is. You take half of a shape, rotate it around itself to come up with the full shape. So if I take this half of a baseball bat, and this is not a particularly well drawn baseball bat, I will say, but then if I go to model sweep, so all of the 3D extrusion type tools, sweeping, and there are other versions of extruding, they're all here under model. So I'm going to sweep it, and I'm just going to leave all of these default settings the same. Okay, and you'll see what it did. It took it and rotated it around itself, so now it's created a round version of the object. So extruding is good for things like this. So walls, those kinds of things. Sweeping is good for around things like table legs and chair banisters and bagels and anything that's got a round sort of component to it. Sweeping is the way to go. And you can, with 3D modeling, you can add, you can subtract, you can intersect, you can section. So you can create very complex shapes by extruding and sweeping simpler shapes and adding or subtracting them in various ways, and we'll be doing a lot of that throughout the semester. So that's a sort of a really basic introduction to the ideas of 3D modeling. This leads into the first project where you're going to be doing some extruding. You're going to be doing some work with views. We'll be doing some rotating. We'll be using a couple of the specific, or one at least, the sphere, specific 3D modeling tools, and we'll be looking at a little bit of rendering. So good luck with that project, and I will see you in the next video. Thanks. Bye.